we have seen how the image is formed in convex lens and concave lens. That is, convex lens will be converging the rays of light falling on it, and concave lens will be diverging the rays of light falling on it. Now we will see how can we construct the ray diagrams. So the image formation or ray diagram formation is similar to that we have done for mirrors in 9th standard. So we will be selecting convenient rays for getting the image, and at least 2 rays are needed for getting the size of the image, or to see if the image is erect or inverted. Now here in this section I have shown you different rays, how they will behave when it is being passed through convex lens and concave lens. So first I have shown the convex lens here, 3 cases are there, and concave lens 3 cases are there. So first is the diagram. So when you are drawing the diagram, first of all what you have to do is you should draw this reference line, then you can show the convex lens or concave lens. Then you should mark the midpoint as O, approximately somewhat the midpoint of this line can be selected as O. Okay, for the examinations in certain cases they will allow you to draw the straight line. That is, instead of drawing the whole lens, you can even draw the straight line for representing the convex lens. Or in order to draw the convex lens, it is also possible to draw the dotted lines and show like this. So this will be convex lens. This is another kind of representation, and if you represent as like this is concave lens. That is also there. One type of representation, that is, instead of drawing completely, you can either show like this or using certain vertical lines like dotted lines. That is also possible, or else you can draw the complete convex lens as lens itself. Okay, now so the central point is the optic center. After drawing the central point, you should draw a straight line which is the principal axis passing through the central point. Principal axis should be drawn. It can be using a solid line. Now after drawing the principal axis, you should select equal distance on either side of the convex lens to show focal length f1 and f2, f1 here, f2 here. So the distance between O and f1 and O and f2 should be same. That can be measured using scale. Now the first ray which I have shown is a ray which is passing through the optic center. So the rule is, if a ray is passing through the optic center, it don't have any refraction, or it will go undeviated. So that ray is shown here. Similarly, for concave lens, you should draw the reference lines, take the midpoint as O. You can show the concave lens completely as I have shown here. Mark equal distance on either side as f2 and f1. So here f1 and f2, here f2 and f1 should be shown. And in this particular case also, if a ray of light is traveling through the optic center O, it will go undeviated. So you can draw a straight line. Now the second ray which we can consider for the image formation is the parallel ray parallel to principal axis. So again you have to draw the reference line, mark the midpoint as O. If you want to complete the convex lens as convex lens completely, you can draw that. Draw the principal axis, mark f1 and f2 at equal distance on left and right. Now the second ray is the parallel ray parallel to principal axis. So the ray should strike which line? The central line. So that is where the refraction is to be shown. Okay, so we are taking only one refraction at the central line. So the parallel ray on striking the lens will get refracted and will pass through the focus f2. So that is the parallel ray after refraction pass through the focus. So that is the second ray which we can consider. Same in the case of concave lens. After drawing the lens setup, you can consider a parallel ray which is parallel to the principal axis, and it should strike the this reference line here. So the refraction happens. How will be the refraction? It will be diverging. Okay, so it will be diverging. After refraction, it will diverge away in such a way that the divergent ray, if we are tracing back, should meet the point F2. Okay, so that means the refracted ray appears to come from the focal point. Parallel ray after refraction from a concave lens will appear to come from the focal point F2. That is the second ray that we can consider. Now the third ray which we can consider is the ray which is passing through the focus or focal point. So that ray, there also after drawing the lens setup, the ray should pass through the first focal point. It should strike the reference line and will be refracted. So since the ray is passing through focal point, after refraction it will go parallel to the principal axis. Okay, so that is the case of convex lens. Now for the concave lens also, you should consider a ray, okay, which is in the direction of focus. So here it is the direction of focus F1. So the ray should, if the lens was not there, it should directly strike the focus. So that is the ray which is pointing towards the focus. When it strikes the concave lens after refraction, it will go parallel with the principal axis. So these three rays are considered. Any of two of these rays can be considered for image formation according to your convenience. Now next we will see each and every situation in which we get the image. Now there are two types of image. It is a real image and virtual image. So real image is formed if after refraction, the rays after refraction if actually meet at a point, then we say that we will get a real image. Okay, and virtual image means if after refraction the refracted rays are not actually meeting, but it appears to diverge from a point, then we name the image there got is virtual image. Now this real image, it can be caught on a screen, or we can obtain the real image on a screen. If you place a screen at the position or at the point of intersection of all the rays, we will get the image of the object. But in the case of virtual image, even if you are placing the screen at that position, we won't get any image. Okay, so virtual image and real image are two types of images which we get when the light is being refracted.